Hey guys, welcome back to the machine learning course for beginners by Uplatz. So in the previous lectures, we have seen how to perform the simple linear regression, right? So we have completed everything about simple linear regression. We have understood the basics of simple linear regression. We have seen a couple of examples on simple linear regression, and we have also implemented the simple linear regression in Python, right? So the next linear regression is the multiple linear regression. Okay. So the multiple linear regression, also known as multiple regression, is a statistical technique that uses several input variables to predict the outcome of a response variable. Okay. So in the simple linear regression, we had one input and one output, one x and one y. But here in the multiple linear regression, it is just a logical extension of the simple linear regression. It has several explanatory variables, that is the several independent variables to predict the outcome of a output variable. Okay. The goal of multiple linear regression is to model the linear relationship between multiple independent variables and one dependent variable. Okay. So in a sense, multiple regression is the extension of ordinary least squares that involves more than one explanatory variable. So you can see the formula and calculation of multiple linear regression. The multiple linear regression, also known as multiple regression, is a statistical technique that uses several explanatory variables to predict the outcome of a response variable. Multiple regression is an extension of linear regression that uses just one independent variable. And MLR, that is multiple linear regression, is used extensively in economics and financial inference. So what multiple regression can tell you? Simple linear regression is a function that allows an analyst or statistician to make predictions about one variable based on the information that is known about another variable. Linear regression can only be used when one has two continuous variables, that is, one independent and one dependent variable. The independent variable is the parameter that is used to calculate the dependent variable or the outcome. A multiple regression model extends to several explanatory variables. Okay. So the simple linear regression is a function that allows an analyst to make predictions about one variable based on the information about another variable. It can only be used when one has two continuous variables, that is, one independent variable and one dependent variable. But a multiple regression model extends to several explanatory variables. The multiple regression model is based on the assumptions that there is a linear relationship between the dependent variables and the independent variables. The independent variables are not too highly correlated with each other. The observations are selected independently and randomly from the population. The errors should be normally distributed with a mean of 0. Okay, so these are the assumptions in multiple regression. The first is that it assumes that there is a linear relationship between the dependent variable and the independent variables. Independent variables are not highly correlated with each other. The output observations are selected independently and randomly from the population. The errors should be normally distributed with a mean of 0 and variance. Okay. So you can see the formula there for the multiple linear regression. y equals b0 plus b1x1 plus b2x2 plus epsilon. Okay, so in the simple linear regression, there was only one independent variable and one dependent variable. But in multiple linear regression, we will have more than one input. So the formula is just the extension of the simple linear regression. So for the simple linear regression, the formula was y equals b0 plus b1x plus epsilon. But here it is extended. If in case the inputs are 2, then the formula will be y equals b0 plus b1x1 plus b2x2 plus epsilon. For example, you can see y equals 30 plus 5x1 plus 7x2 plus epsilon. Okay, so here 30 is the intercept and 5 is the slope for x1 and 7 is the slope for x2. Then y1 equals b0 plus x11 b1 plus b2 x12 plus b3 x13 and so on till bk x1k plus epsilon 1. Similarly, y2 equals b0 plus b1 x21 plus b2 x22 plus b3 x33 and so on till bk x2k. Similarly, yi equals b0 plus b1xi1 plus b2xi2 plus b3xi3 and so on till bk, sorry, it's multiplication not addition. So b0 plus b1xi1 plus b2xi2 plus b3xi3 and so on till bkxik plus ei. Okay, so what is this x11 x12 x13 and what is x21 x22 x23 and so on? You will understand it in the upcoming slides. Okay, so this is the formula for the multiple linear regression. There is no single y, there are multiple y's. Okay, and here you need to perform some matrix operations in linear algebra. So the linear algebra operations are explained in the module number 1 in the introduction about linear algebra. Okay, so just go through that, they are essential here. So y equals xb plus epsilon. Okay, so we have to split y into y1 y2 y3 y4 and so on till yn. Similarly, x equals, the first column will be 1 for the ease of operation, then followed by x11 x12 x13 and so on till x1n, then x21 x22 x23 and so on till x2n, then xn1 xn2 xn3 and so on till xnn. Similarly, the beta value equals b0 plus b1 plus b0 b1 b2 b3 and so on till bn, and epsilon equals e1 e2 e3 e4 and so on till en. So just have a look at this slide. Okay, so then it becomes, this is the predicted output. Okay, so y cap equals x multiplied by b cap, then b cap equals x transpose multiplied by x to the inverse. Okay, then multiplied by x transpose multiplied by y. So this is the main formula for the multiple linear regression. So b cap equals x transpose multiplied by x to the power minus 1. So all these things are taught in the model number 1, how to find the inverse of a matrix and all. So just go through it. Then multiplied by x transpose multiplied by y. So E, the error is the actual observed value minus the predicted value. So as usual, the errors should be minimum. Then y cap equals x multiplied by b cap. So x is nothing but x multiplied by, no sorry, the b cap is nothing but x transpose multiplied by x to the power minus 1 multiplied by x transpose multiplied by y. So we have substituted the value of b cap. That complete equation we write it as h, that is the hypothesis. So this is what something happens. Okay, so we have to operate this expression x multiplied by x transpose multiplied by x to the power minus 1 multiplied by x transpose multiplied by y. So this becomes hypothesis multiplied by y. Okay, so we have written the h value there, the hypothesis. Okay, so we will solve the expressions, we will solve the problems in the later slides. So here you can see there are two x, right? There are two inputs, factor 1 and factor 2, and there is one y. So you can see in the simple linear regression it was just two columns, one x and one y, but here we have more than one x. Okay, so we have more than one x here, that is x1 x2. So all the column, all the values of the column factor 1 will be x11. Okay, then all the values in the column factor 2 will be x22. All right, so it is like x11, then x21, x31, x41, that is 41.9 is x11, then 29.1 is x12, then 43.4 is x21, then 29.3 is x12, like this it goes on. Okay, so we need to solve using the formula. So just we have shown you this formula, right? x11, x12, x13 and so on till x1n, that is the values in the first row. Then in the second row it becomes x21, x22, x23 and so on till x2n. Like that, the last row is xn1, xn2, xn3 and so on till xnn. So let's use that here. So 41.9 is x11, 43.4 is x21, 43.9 is x31, then 44.5 is x41, then 47.3 is x51 and so on. So let's use it here. So x equals this, y is 251.3, 251.3, then 248.3, 267.5, like this and so on till 349, right? So the y value is 349, the last value. Then b cap. So b cap, what's the formula? What was the formula for b cap? B cap equals x transpose multiplied by x. Okay, so that is here. we have we have already kept the multiplication, that is x transpose multiplied by x. So the answer is 17, then 941, then 525.3, then 941, 527, 54270, then 29286, then 525.3, 29286, 16254. So this is the answer of x transpose multiplied by x. Okay, to the power minus 1. So we have to find the inverse of this. Okay, multiplied by x transpose. So you can see the x transpose here multiplied by y. So this is a operation of a matrix and a vector. So as you know, we have learned it in the first module that a matrix multiplied by a vector will also be a vector. So we have got this vector 4902.8, 276610, then 152020. Okay, so this is a vector. Then we have got the b cap value as minus 153.1, then 1.24, then 12.08. Okay, then b cap equals b cap 0, b cap 1, b cap 2, because here you can see that we have two values of x. Okay, so the formula will be this one, what we saw here, b0 plus b1x1 plus b2x2. That's why we have b0, b1 and b2 here. All right, so b cap 0 is minus 153.1, then b cap 1 is 1.24, b cap 2 is 12.08. So when you solve the equation carefully, you will get b cap value, b1 value, b cap 0, b cap 1, b cap 2 values as minus 153.51, then 1.24, then 12.08. Okay, then y cap equals b cap 0 plus b cap 1 x1 plus b cap 2 x2. We substitute the formulas of b as minus 153.5 plus 1.24 x1 plus 12.08 x2. Okay, then now it is easy to solve y1, y2, y3, y4, y5 like this. Okay, so for example, y cap I equals minus 153.5 plus 1.24 xi1, okay, plus 12.02, 12.08 multiplied by xi2. For example, y5, you can see a solved example of y5, that is minus 153.5 plus 1.24 x51. What is x51? In the table you can see x51 is 47.3. So that is substituted here, 47.3 plus 12.08 multiplied by x52. x52 is 20.9, 29.9. So that we have got here the predicted value of y5 is 266.3. But the observed value here is 273.0. Okay, so what's the error? Error is 273 minus 266.3. So that is the error. All right, so it's solved here. E5 equals y5 minus y cap 5, that is the observed value minus the predicted value, that is 273 minus 266.3, which is 6.7. Okay, so like this the multiple linear regression is solved. Then y cap, here we are providing a new set of x values, that is 47 and 31. When the new x values are 47 and 31, we substitute them here. So minus 153.5 plus 1.24 multiplied by 47 plus 12.08 multiplied by 31, which is equal to 279.26. So our answer is 279.26 for the new set of x values 47 and 31. So this is quite a lengthy process to solve the expressions, but if you know the operations, then it would be easy to solve. So by applying this formula, so we have solved one example for this table. We will solve many other examples. So if the input values are 3, then you will have B0, B1, B2 and B3. Okay. So just have a look at this. We will continue the next example in the next lecture. All right. So any doubts, you can mail us. Try to solve these with a very simple example. Okay. Just take two input variables x1, x2 with some very simple values and apply this formula b0 plus b1 x11 b2 x12. Then by using this formula you can solve them easily if you take some simple values for x and y. Okay. So we will continue it in the next lecture. All right. Thank you.